So hello everyone. In today's video, we'll be discussing all about forces and magnetism. So this is level 5, which means grade 4 in Indian standards, Cambridge Science. So here specifically, we'll be talking about this topic, that is forces and magnetism. And this we're going to help understand how Cambridge Science is different from Indian curriculum science, and how much in-depth analysis and understanding they do right from the very beginning. So certainly I'm going to draw your attention towards force diagrams, which is an essential component of this topic. And I remember that I was introduced to force diagram only in my 11th standard, especially in the H.C. Verma books, when he had to do a lot of forces on inclined plane, and there was friction, there were normal forces, etc. And I had no previous understanding of it. So imagine if a child is doing this from the very beginning, they would be having such in-depth understanding of the subject. So again, keeping in mind, it doesn't demand the child to go intense with the topic. They have a very spiral way of introducing any topic in Cambridge curriculum. So they're going to revisit it every year in all the grades. And very soon, when they are in actually 7th and 8th standard, they're going to demand in-depth analysis of these topics. So right now, they just have to understand it. So I'm just going to show you, and then of each and every topic. So here I divide my video in two parts. And in my next video, I'll talk about magnetism, so that it becomes a very short and sweet video for you to revise before exam. So here they're talking about gravity and normal forces. That's the first force we need to understand. Post that, what do we mean by applied forces, which is not and pull, and how it makes the object move. They'll talk about gravity and satellite, that Earth has its own pull and Moon has its own pull, and that's the reason why Moon revolves around the Earth in a fixed orbit. Based on the same category, they're gonna design artificial satellites, and that's what they will be talking about, how scientists developed artificial satellites following principle of Moon. Now comes friction, air resistance, water resistance, and upthrust. So is an extremely important uh, topic. So I'm going to give you in-depth analysis of the force diagrams in this particular chapter. And then 5.4 is multiple forces, that the child should know how a lot of forces are acting on one particular object at the same time. And magnetism is going to take after we finish forces. So showing you my notes and how I'm going to do it. So firstly, the first topic is gravity and normal force. And I am considering object be at rest. The first case is object at rest. So imagine this is a table and this is a wooden block. So what are the two forces acting on it? So definitely there is a gravity, which is G, and there is a normal force, which I have marked as N. You will ask me, why do we have a normal force? Why gravity? So definitely because we are living on the planet Earth. So by default, we will experience a gravitational pull, a gravitational force, which keeps us binded to Earth's surface. Now, what is normal force? Suppose if there would have not been any normal force, which is like an equal and opposite, this block that you see would go inside. Say that if gravity is greater than normal force, this brick is going to break in through the table and it's going to fall down. But at the moment, the weight of the brick is just the right amount to balance it on the table. So that's what it is. Here, normal force is equal to gravity, and the object is at rest. Now, for what does applied force mean? Along with this, we have to understand that these applied forces vary for different states of matter. So when it is solid, it's going to be called differently. When it is liquid, it's different. And when it is gas, it's going to be called different. Let's consider the case of solid being in contact with solid. So applied force is a push or a pull that is exerted on any object. So if the same block that you see on the wooden box or on the wooden table, where there is a G, there is a normal force. Now I am going to push it. So if I'm pushing it, this is the point of application, right? It's a push. And if I draw the same diagram and I have to pull it, because I want the motion to happen in this direction. This is very important, huh? Where to push, where will be the point of action for push and pull? Everything depends where the object is moving. I'm going to give you 3 cases so that you develop a solid understanding of what I'm talking about. So again, there is a G, there's a normal force, and here I'm talking the motion to be on the right side. And if I have to pull, I'm going to pull it from this side. So this is my pull, this is my push. Okay, so this is my applied force. In general, instead of push and pull, I'm going to say applied force, which is the external force acting on the brick. Now, this is going to cause a motion, and as soon as the object changes from rest to being in motion, they experience a force, an opposing force, which is known as friction. So if the motion is happening in this direction, if a force is acting in this direction, friction is going to be opposite. And remember, friction is called friction when there are two solids object together, two solid objects together. So here I am pulling it, motion is happening in this way, and friction is in this direction. Now suppose I want the object to move in this direction. Okay, so this is my motion. And to push, so I'm going to push it from here, and friction is going to be the opposite direction here. Friction always acts in motion, and it always acts between two surfaces rubbing against each other. And definitely there is going to be a G and a normal force. Similarly, if I want the motion to be in this direction and I have to pull it, it really matter where the point of application is, the friction is going to be in the opposite direction of motion as well as applied force. So this is how we complete 5.1. If I show you the book here back again, you will be surprised to see that I have explained this. Now I need to enter the ID password, so I can't access. I'm going to directly tell you from the notes. Okay. So this is the force diagram when we talk about very simple topics of, normal force and gravity. And then we talk about applied forces, that is push and pull. The next topic was gravity and satellite. So this is Earth and this is Moon. Why Moon is moving in a fixed orbit around the sun? So this is Moon and this is Earth. We know Earth pulls everything towards itself. So Earth is pulling this object towards itself. So the direction of gravity is always pointing towards Earth. So this is Earth's gravity. I'm going to write it as GE. Moon also exerts a pull to pull Earth, right? So it's going to pull the Earth towards itself. So I'm going to call it as gravity of the Moon. This is gravity of the Earth. Now here we know that G is Earth's gravity is greater than the gravity of Moon. Still, it is that not that great. Because if I say it's extremely, like, if Moon doesn't exert any gravity, if Moon has no um, pull, then what is going to happen? Think about it and let me know. Meanwhile, I'm going to reveal the answer. In that case, the Moon is going to be stuck on the Earth's surface because Earth's pull overcomes pull. But at this moment, since both of them are exerting some amount of pull towards each other, they have settled down for this particular distance from the Earth. So Moon is revolving in a fixed or orbit, and it's always going to be moving in the same orbit. Now, again, if I ask a scientific question to you, what if Earth's magnetic power becomes zero? In that case, Moon's magnetic power, Moon's pull is going to attract the Earth, and Earth is going to come to Moon and get stuck on it, right? But it's not possible because Earth is so big and it has a magnetic field which is very strong. In a similar way, if I say, what if I switch off the magnetic power of the Moon? Because Moon also has some gravity on it. So then Moon is going to come and directly stick to Earth's surface. But it is not happening so, because Moon is also exerting some amount of pressure to keep itself away from Earth. On the same principle, um, scientists designed these satellites, which have so many uses in our daily life. It comes for weather forecast, telecommunication, navigation purpose. It's really quite useful, and they have designed it following the same principle of Moon's gravity. So if I go into the trajectory path, it's going to be very difficult for you to understand at the moment. So we will just skip it. So they launched the satellite in a way that after it, reaches a particular layer of the atmosphere where there is no gravity, or if there is gravity, because to take the pictures, it depends at what distance these satellites are. So I'm not going to go in depth because that's not what we are learning at this level. So I'm just going to skip that. Next comes 5.3, which talks about air resistance, friction, air resistance, um, friction, water resistance, thrust, upthrust. All right. So what exactly are these? As I told you, friction is an opposing force. Friction is an opposing force, and it happens when we have two solids in contact. Okay, like a ball rubbing over a floor. When we have two solid surfaces, then we experience friction. Water resistance is when a solid is in contact with water. So I would say solid plus water. There, the solid is going to experience water resistance. And air resistance is the same thing. Here we have a solid being in contact with air. Now comes thrust. So applied forces for air and water surface is known as thrust. So I'm not going to call it as applied force, and I'm going to call it as thrust. Similarly, what is an upthrust? Upthrust or lift. It's actually the normal force, but we don't call it. Normal force is not called as normal force in air and water medium, but it is called as upthrust and lift. Okay, so these are the keywords and vocabulary that you need to understand, and then the force diagram is going to become very, very easy for you. So for example, if I'm drawing a boy riding his bicycle on a rough surface, so what would be, and he's moving in this direction because that's where the pedal and the handle looks like. So he's going to move in this direction. So point of application of force is here. So I'm going to say applied force since it's the surface. So here is applied force. Certainly the friction is going to be out on the opposite side. The tire and the road is going to experience friction. Now there would be a gravity and there would be a normal force. Now, there's something else that will also be there, and that is known as air resistance, which will be opposite in the direction of applied force. Since he is moving in the forward direction, he's going to experience air resistance. And because he's moving in quite a speed, so he's going to experience good amount of air resistance. Now, similarly, if we have a bowling pin, this is a bowling pin, and this is the ball. So after putting some pressure, like I'm throwing the ball, pushing it, right? So I push the ball. This is the push. So I'm going to say applied force. So applied force makes the ball move in this forward direction. I'm going to call it as applied force. It's going to experience a friction, definitely. There is a gravity. And then there is an upward force, and there's a normal force. I'm calling it as normal force because these are two solids together. Now, since it is in a closed environment, this ball may not experience air resistance at the moment because this is something that happens indoor. In a similar way, if we talk about a truck, okay, a truck moving in a particular direction here. So this is my applied force. So the motion is this side. Since it's being in contact with the road, it's going to experience friction. Okay, there would be a gravity and there would be an upward normal force. Normal force. It's also going to experience air resistance in the opposite direction. So there's certainly friction, but since this is solid being in contact with air, it is going to experience air resistance. This portion, as I explained it to you over here, what is water resistance? When solid comes in contact with water. Air resistance when solid comes in contact with air. And friction when we have two solids rubbing against each other. So these are the multiple force diagram as well as the topic that I want to talk about. We've spoken about air resistance, and I want to take two more example of air resistance here for you. Imagine this is a paper aeroplane, and these are the forces that I want you to name. So how will you call this? Imagine this is aeroplane and this is air. So What is this called? What is this called? Certainly the downward force is gravity, and upward force, you will call it as a normal force, right? And this is moving in front, so you will call it as applied force. Here you will certainly call it as air resistance because we are in contact with the air surface. Air resistance, and it's also known as drag. But I'll tell you that these two, normal force is wrong and applied force is wrong. Whenever the surface changes to air or water, we call the normal force as upthrust. So upthrust is going to be in water, and when it is air, we don't call it as upthrust and we call it as lift. And applied force is known as thrust. So I'm going to repeat it again. I'll change the color and I'll tell you. Certainly, this is gravity and this is the normal force. But remember, this is which medium? This is air. So in air, we don't call normal force as normal force, but we call it as an upward force. An upward force, you may say it's upthrust, but upthrust is experienced only in water. So here we will call it as lift, and it is very easy for us to remember because aeroplane lifts up in the sky, right? So this is lift. And applied force is not called as applied force, but it is called as thrust. Similarly, and this is air resistance and this is drag. Similarly, if we talk about a parachute, okay, there are two types of parachutes here that I have drawn. Here there is a person flying down, a person flying down. Now, here I want you to draw the force diagram, but before that, I also want to ask you, how is the direction of motion? How is the direction of motion? Is it left or right? Or is it up and down? Definitely it is up and down, so it is down. This parachute will always come down. It is not going to go left and right. So if the motion is happening in this direction, where will be the opposing force? Where will be friction? Now you'll ask me, ma'am, we don't say friction when it is air. So you got it absolutely right. What do we call an opposing force when it is air in air medium? We call it air resistance. So here, the air resistance is in upward direction because the parachute is coming down. Again, the air resistance is up. So there is certainly a gravity acting downward. Okay, there is an applied force acting downward. But here I will that I need to apply any force. It is just the natural pull of the gravity which causes this heavy weight or any weight to come down. So there's just two forces acting right now, that is gravity and air resistance. That's it. The next condition here is, since the surface area of this parachute is small as to this, there is less air entering this as compared to more air entering this. So who is going to get more air resistance? A parachute or B parachute? Give it a thought and tell me. Who is going to experience less air resistance? A is going to experience less air resistance than B. So who is going to take more time down? B, because it's experiencing hindrances, some obstacles, some resistance. So it's going to come slow as compared to this parachute, which will be faster in coming. So if we consider the designing part, can you tell me, for safe landing, how should be the canopy, the fabric size of the parachute? Should you make it big or you should make it small? I would definitely want to be in this parachute because it's going to give me a smooth landing. It's not going to come down in a speed. It's going to be little slow. So I'm going to be much more relaxed. My chances of getting injury will be less in this parachute. So this is a better designed parachute. Now, we are still in the medium. I have not discussed water medium. Let me show you another example, which is hot air balloon. I have chosen hot air balloon because it not only moves up and down, while landing and taking off, if you have been in a hot air balloon, but it also moves left and right. Okay, so this is a hot air balloon. So only when it is going up, taking off, it's going to move and it's going to get some air resistance. So if motion is happening in up, so air resistance is going to be downward acting and vice versa. And then there would be cases when the hot air balloon moves left and right also, because it covers the entire sky. It tries to show us the top view of the city from different angles. So the hot air balloon moves like this also. So if the applied force is in this direction, the air resistance is going to be in this direction, because the motion is in this direction. So friction resistance is always in the opposite direction. There is a gravity and there is an upward force, which we call it as normal force. But since it is air medium, I'm going to call it as lift, and force to call it as thrust. Okay, so this is as simple as what you see. You can pause this video right now and you can do your own force diagram to understand it. There are 4 forces acting. I want you to name them. Name each one of them. Now, if this is the motion, for you, you have to find the same hot balloon move in left direction. Then how will the force diagram change? Okay, so that is your homework. What is this called? What is this called? What is this called? Now, because I also have to put you with the answer. So answer, give me solution, and then you can tally your answer with my answer. Since it is moving in the left direction, the thrust, which is applied force, is in this direction. Opposing force, that is air resistance, is in this direction. Gravity is certainly down. Normal force is up, but it's air, so we will call it as lift. This is your answer. Well done. Now we talk water medium. In water, we experience a lot of force. If the if the ball is resting, ball at rest on water surface, will it experience any up? No. There's down and there is a normal force acting on it. Okay? And this is gravity and it is not moving. So there would not be any resistance, any friction, any water resistance, right? This is ball at rest. Now, imagine this is my ball and I am applying a force on it. I am pushing it down. This is my applied force, which I will call it as thrust. Apply force down, it is going to revert back as up thrust. The water exerts a force in the upward direction. Certainly there is a G, and the point of application of force is downward. So the ball's movement is going to be up and down, and it's not going to be left and right. So there would not be resistance for the flow. but there's certainly going to be an upthrust. Okay, now consider the case of a ship. So this is the ship. Here there is G. Ship is moving in this direction. So this is my thrust. Okay, and here it's going to get water resistance. Now what is going to be here? It's also going to get some air resistance because it's on the surface of air also. So here, since this portion is not solid and it is liquid, here it's going to experience water resistance. Okay, it's going to experience water resistance. It's very important. The whole thing, if it is moving in this direction and it is in water, it is going to experience water resistance in good direction. If we go in depth, we will definitely say, since air is also here, so it also experience another opposing force, that is air resistance. But since we are talking about just water surface, this is what it's going to experience. And there's going to be an upward force, which I will not call lift here. I will call it as up. So this is how the force diagram works. The object is in motion. I want to test your understanding, and let's take this example and see how much you have understood. Okay, so this is water. This is my boat, and this moving in motion. I have just given you the motion, or if I haven't given you the motion, by having a look at the steering wheel, you will know which direction the ship is moving. Okay, sometimes you don't know the motion direction, but a steering wheel certainly tells you that it's going to move in this direction, like this. I want you to write down the names of all these forces, 4 forces, okay? And check your work. 1, 2, 3. So, first thing that you need to do is pause the video, draw the diagram, write your answer, then play the video and check your answer. So pause it now. Now let's check your answer. This is gravity, and since it the normal force, the normal force that acts opposite to gravity is known as upthrust. Here, this is opposing force because applied force is here. This is applied force, but we don't call it as applied force. We're going to call it as the thrust. So thrust is in this direction. So this is going to be water resistance or drag. So the force diagram is as simple as this. I hope you got your answers right, and give a pat to yourself if it was actually right. And if not, I want you to rewatch the whole video once again. You can certainly take breaks in between, children. And once you are watching this video, I want you to do the self-study of reading the whole chapter, that is 5.1 to 5.4, and solve the back exercises, in between exercises, and go through the worksheets provided by the school. Now, in the next part of this video, I'll be discussing about magnetism. So don't forget to watch that. All the very best for your exams. Bye-bye.